In the last session, we have discussed about uh, normal random variable and two of its problems. In that particular note, the note is already there in the Google Classroom. You can find that this note has already, the note has two other problems, which I haven't discussed, but I'll ask you to look at the problem and try to do it by yourself. Try to do the problem by yourself. I'll not recommend to do the problem only. I'll ask you to try to imagine the physical situation from which the problem can be derived. I'm again and again saying that our world is actually based on statistics, be it COVID-19 situation, be it political scenario of our country or political scenario of the world, whatever it is, entire information which you get in news channels, in newspapers, in Facebook's, WhatsApp forwarded messages, everything is based on statistics. The statistics may be false, may be wrong, may be right, may be correct, whatever, maybe partially right, maybe exaggerated, whatever. But we are actually on a fire, which is called statistics. This fire can burn us, or we can just get heated by the fire beneath us. Okay. Or it may not affect at all. Okay. So that is the thing. So statistics is a kind of fire on which we are sitting. We actually believe what an authentic source says to us. Sometimes you also believe the fake news. Okay. So therefore, whenever you deal with statistics, deal with it carefully. So I always recommend all of you to think of the physical situations from which the problems can be derived. And if you guys, if you sit together to discuss a statistical problem, and if you play this sort of game, this particular situation, suppose this apple eating problem, which I discussed in the previous session, is on the plate, and two of you are sitting together and thinking of the physical situations mentally, then you'll find that your thinkings are independent of one another. Oh, I forgot to tell you one thing in that apple eating situation, that why capital X and capital Y were independent. Okay, because the covariance covariance of XY, that portion vanished. Why? Because apple eating habits of females and apple eating habits of males, they are independent. Oh. So if you play this sort of game, what will happen is that both of you will come out with a different physical situation. Okay, so you'll say to your friend that, yeah, this may happen. Your friend will say that, okay, this may happen, and you will find it very interesting. I used to play this sort of game with my friends when we used to study statistics in graduation course. Anyways, my next note is, I don't know whether I'll be able to complete this particular thing the second session, because it is a little bit, I mean, it requires a fair amount of time to discuss this situation. The topic is percentiles of normal random variable, and it is very important. Percentiles of normal random variable. There is a difference between the word percentage and percentile. People often think that percentage and percentile, they are same thing, but they are not. Okay, what is percentile of this normal random variable? Let us try to figure it out. To understand this, I have drawn a figure, a standard normal curve. The origin is at z equal to 0, and the curve is stretching from minus infinity to plus infinity. And without any loss of generality, on the right hand side of this curve, I have considered a point which is called z alpha. This z alpha, since it is residing on the right hand side of the point z equal to 0, this point is obviously a positive point. And we are considering alpha, the real number alpha, to be lying between 0 and 1. Why is it so? Because as you can see that if I define, if I'm interested about the probability of Z greater than Z alpha, means if I'm interested about this region, if I'm interested about this region only, then I am defining this region, the probability, the area of this region to be alpha, or probability that the random variable capital Z will be greater than this particular value Z alpha is alpha. So alpha is my probability, and therefore I have considered alpha to be lying between 0 and 1. This is the reason for which I have done so. Let alpha is equal to 0.025. So for example, and this particular thing which I am discussing right now is also very important in hypothesis testing and in subsequent topics which will be discussed. Alpha equal to 0.025 I have considered a particular value. So suppose according to that, I have written down the equation which gives you that probability that the random variable capital Z is greater than Z alpha. This probability is 0.025. What we usually do, what we used to do, first of all, let us try to think, recall the thing. In the previous note, we drew the normal curve. We marked the origin at Z equal to 0. We marked a point over here or a point over here, and the probabilities were found according to the situation. Here, the scenario is just opposite. Here, the probability is given to you. You are supposed to find what that point could be. So, therefore, this particular problem is a very different from the previous one discussed. So, once the probability of this particular region is given to me, can I find the point for which this probability can be obtained? We are going to study that scenario here in this particular case. Now, since probability of Z greater than Z alpha is 0.025, now from complementary event probability, probability of A bar equal to 1 minus PA, okay, probability of Z less than Z alpha can be written as 1 minus probability of Z greater than Z alpha. It would be nice if you write, actually, probability of Z less than Z alpha is actually 1 minus probability of Z greater than Z alpha. I mean, an equality sign will be there. Probability of Z less than or equal to Z alpha will be 1 minus probability of Z greater than Z alpha. But you know, for continuous probability, these things are same. Whether you include the equality or you do not, doesn't matter, doesn't affect. So therefore, I have written it as probability of Z less than Z alpha. Okay, you can think, where has the equality gone? So I have written it out, and we are given probability of Z greater than Z alpha to be 0.025. So probability of Z less than Z alpha can be found as 1 minus 0.025, which is 0.975. So we have found this particular probability. Now, this thing which I have written over here, this thing is, this particular chart is the portion which I cut from the table which I showed in my previous slide, previous session. The table, only this portion where the point 1.9, the row heading 1.9 was there, that has been taken into consideration. All column headings have been retained, 0.00 to 0.09. You can compare this particular portion with the chart given. You will find that the same values have been taken into consideration. I am interested in finding, now I am looking at the value. What value have I obtained over here? What probability have I obtained over here? 0.975. Now you see that the values are changing. For probability of Z greater than Z less than. Now what is this value? This value, this probability, if you can recall, This particular chart has been for z less than x, if you can recall. So actually this is representing different probabilities. This probability is for probability of z less than 1.9. This is for probability of z less than 1.91, and so on. Last one is probability of z less than 1.99. Okay, and this one is for probability of z less than 1.96. These probabilities are given. Now if I consider this and 0.06, we get this one. And see, the probabilities, the values of the probabilities are 0.9713, 0.9719, 0.9726. In this way, at this point we get 0.975. We may not get the exact probability as per our situation, but we can get, if suppose here we have obtained 0.9749. Suppose the probability has come out to be 0.97, or suppose we have got 0.9746. So we shall consider the probability which is very near to it. So fortunately we have got the same thing in the chart. Okay, so this probability 0.975 is actually appearing for which value of z alpha? From the chart it is given that it is appearing for 1.96. It is appearing for z alpha is the value of z alpha for which this probability is happening is 1.96. Okay, and what was my alpha? We started with alpha equal to 0.025. So since z alpha is 1.96 and alpha was 0.025, so it is pretty obvious that z 0.025 will be the value which is 1.96. So if we consider alpha to be 0.025, probability that z greater than z alpha is 0.025, and consequently we can find the probability that probability of z being lesser than z alpha, for which the z alpha consequently from the probability table can be found out to be having certain value. Here in this particular case the value is 1.96. I hope you have understood the calculation. Okay, I'm erasing these portions. So what does this imply? This implies that the calculation has implied that 2.5% of the time, or out of 2.5% means 2.5% means okay, and this means 0.025. That means out of 1,000, 25 times standard normal random variable will exceed 1.96. Okay, so 2.5% chance is there the standard normal variable will exceed 1.96. That we have found over here. So we started with probability of z greater than z alpha is 0.025. The value has come out to be 1.96. That is 2.5% chance that z will exceed this value 1.96. And consequently we can say it, we can put it in another way, that 97.5%, because if I subtract it from 1, okay, so 97.1%, 97.5% of the time standard normal random variable will be less than 1.96, because we have got 0.975 over here. So 97.5% chance that z will be less than 1.96, and 2.5% chance is there that z will be greater than 1.96. Now look at this equation 2. From 2 we say that 1.96, this value which we have calculated, this value 1.96 is known as the 97.5 percentile of the standard normal distribution. Okay, so this value Z alpha such that probability of Z less than Z alpha is having certain probability, that is called the 97.5% percentile of the standard normal distribution. Okay, this is called the percentile. So in general, we can write it as probability of Z greater than Z alpha is alpha. We started with that, and probability of Z less than Z alpha is 1 minus alpha. Then Z alpha is called 100 into 1 minus alpha percentile of the standard normal distribution. Why 100 into 1 minus alpha? Because you see, we found 0.975 over here, but when we are defining the percentile, we are multiplying this by 100. And then we are writing it said 100 multiplied by 0.975 percentile. This is called this, I mean, 100 multiplied by 0.975, that is called the percentile of the standard normal random variable. So therefore, in the general definition, we are not saying that alpha is the percentile or 1 minus alpha is the percent. Alpha is not the percentile. You have to consider this equation, this inequation or equation to get the percentile. And you cannot say that alpha 1 minus alpha is the percentile. You have to multiply the value by 100, and then you can say that, yeah, that value is the percentile of the standard normal distribution. I hope you have understood this situation section. Okay, so next we are going to do a problem. The problem is done over here. I'm going to explain the situation only. Never forget this particular portion, that percentile portion, because this will be required in hypothesis testing also, and this is very important. The attendance at home football games of a certain college is a normal random variable with mean 52,000 and standard deviation 4,000. Attendance at home football games. The certain college is a normal random variable with mean 52,000 and standard deviation 4,000. Which of the following statements are true? Now 52,000 and 4,000. Now this first line I'm not going to explain. As I have told you, when a problem is given in front of you, you just think of the situation. You just think of the scenario you are having. Okay, different people can come out with different scenarios. Which of the following statements are true? Over 8% of the games have an attendance of over 46,000. The attendance exceeds 58,000 less than 10% of the time. So let us try to do it. Over 8% of the games have an attendance of over 46,000. Let capital X denote the random variable which defines attendance. According to the problem, alpha be the probability that the attendance is over 46,000. So we can write it as probability of X greater than 46,000, which is equal to alpha. Now, you can convert this normal random variable to Z. You can convert this normal random variable to Z, and then with further calculation, you can come up with Z, probability of Z less than 1.5, which is alpha. And from the probability chart, as I have shown you earlier, that alpha can be found out to be 9.23. So 9.23 here, 0.9323. So 9.23 here will be your percentile of the given random variable capital X. And therefore, over 8% of the games have an attendance of over 46,000. We have got the answer to be 9.23%, which is higher than 8%, and therefore this statement A is correct. This statement A is correct. Just a minute. Okay. Now, Here I have not shown the second problem. The attendance exceeds 58,000 less than 10% of the time. I have also only mentioned that statement B is correct, but you have to verify by this. You have to verify this particular thing by yourself. I am actually leaving this particular portion for you to study by yourself. Okay, this is a new, this particular section of the note that is called sampling distribution is a new section. I'm not going to discuss this particular section right now. This sampling distribution section will be discussed with section B students today in the afternoon, and you will get to know it from the video. Tomorrow we have class at 1:40. There we are going to explain. I'm going to explain further. I'm going to further on these particular topics. I am taking a considerable amount of time to discuss normal random variable, and I'm trying to explain the scenario page by page. It's because you can say that normal random variable is the most important section of your syllabus. If you do not understand normal random variable, if you do not understand normal population, if you do not understand normal distribution, then nothing of the subsequent chapters like estimation theory, sampling theory, hypothesis testing, nothing will be understood by you. So you just give a fair amount of time from your end also to study these things. I'll ask you to go through this first section of first part of the note again and again, and try to put this definition of percentile inside your head, and you have to remember it always if you want to do the statistics. So with this, I'm going to conclude my today's session. Okay, I'm not taking much of the time. You can ask your English teacher to start her class at 11 a.m. at the scheduled time. So we are going to meet again tomorrow in our scheduled time. So till then, bye. And you just go to the video, the earlier videos and the video which will be uploaded tonight of our class.